Hi, and thank you so much for joining me. In this segment, we're going to be talking about heating curves and cooling curves. So let's go through these phases and the processes in a picture and particle diagram, and then I'm going to make a graph so we can link this all together. Now, a solid has a very fixed and definite shape, and it has a fixed volume. So both of those are independent of the container. It's going to take this shape and this volume regardless of what container we put it into. Now, if I add heat to that ice cube, the particles are going to start vibrating more. In other words, I'm going to increase my kinetic energy of the molecules. That increase in kinetic energy would in turn be measured as an increase in the temperature. Now, we reach a point where we hit the melting point. So the molecules are vibrating, 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 and pretty soon they gain enough energy that the molecules can start to slide by one another. They start to break their attractive forces. And remember, it takes to break. Now, since we're talking about attractions in this case, we're talking about potential energy. So as we change from a solid to a liquid in the state called melting, okay, we're breaking attractions. That takes heat to break, so Q is positive. I like to ask my kids to pose this question. Would putting it on the stove help the process? If the answer is yes, it's an endothermic process. The stove is providing the energy needed for my system to undergo the process. The reverse of melting is freezing. Okay, and in this case, heat is released. If we put it on the stove, you can't freeze an ice cube by putting it on the stove. So if the answer is no, it's exothermic. Q is negative. It's exothermic. So let's go back to the melting portion of this. Let me change colors, maybe that'll clarify. If I increase the heat, I'm now increasing the potential energy by breaking forces of attraction. And what happens, I'm not changing my kinetic energy. And if I'm not changing my kinetic energy, my temperature remains constant. CST stands for constant. So during a phase change, there's no change in temperature. Really big take-home lesson there. Okay, let's look at the next one. Now we have all liquid. So the liquid has a fixed volume, but its shape is dictated by the container. So now we've got all liquid. We continue to add heat. We're now going to be increasing the kinetic energy, so we will observe an increase in temperature until we reach the phase change. Pretty soon, we get enough kinetic energy that these molecules can break free from one another. And that process, be careful, it's called vaporization, or you're at the boiling point, but the process is called vaporization. Can't spell and talk at the same time. Yeah, I did that. No, I didn't spell it right. Vaporization. There we go. Evaporation occurs below the boiling point. Okay, Q is positive because boiling water, it helps to be on the stove, so that's an endothermic process. The reverse process is called condensation. Okay, Q is negative, and it's an exothermic process. Okay, well, what's happening here? As we add heat, we are increasing the potential energy because we're breaking attractive forces. And potential energy in chemistry is at a rudimentary beginning level. We can think of it as all about attractive and repulsive forces. and it takes energy to break, So increased potential energy, kinetic energy is not changing, so temperature is constant during a phase change. Okay? And then after the phase change, as long as we can contain the gas, what we're going to see, gases take the shape and the volume of their container. As I add heat, the gas starts moving faster and faster, so I see an increase in kinetic energy, which is measured in the lab as an increase in temperature. Okay, so now very quickly, I want to sketch out what that would look like graphically. Okay, so let's take a look. So, whoops. So I've got to have my y-axis and my x-axis. And if you're one of my students, you should be able to sketch out this graph. So just FYI, temperature is going to be on the x-axis, either heat or sometimes they'll put time that a constant heat is added. I like to do heat. Okay, so the first segment we can do is we can heat a solid. We're increasing kinetic energy, so we see an increase in temperature. And so what that would look like is this, that diagram from above. We would be heating a solid. Then we're going to reach a phase change, the melting point. And you notice the temperature is constant. When the temperature is constant, that's the melting or freezing point. Okay, so that is represented in your particle diagram by this picture. Notice here we have only solid, here we have solid and liquid. Now, once it's all melted, we have liquid, and when it's all liquid, we start increasing kinetic energy. And if it increases kinetic energy, it increases temperature. Okay, so that would be this picture here. This is pure liquid. Then, and this takes more energy, then we're going to vaporize. So when we vaporize, we have both liquid and gas present. And so that would be this picture. Notice we have both liquid particles and gaseous particles present. Notice too that my temperature is constant. So at the boiling point, temperature is not changing. Okay? And then once it was all boiled away, then I'd start to see this increase in temperature as I increase the kinetic energy of my gas molecules. So here I would have only gas. So solid, solid and liquid, liquid, liquid and gas, and then gas. Okay, so this would be an issue of, let's do this. Here we've got kinetic energy changes. Here we have primarily potential energy, kinetic energy, potential energy, kinetic energy. Okay, now if it is a heating curve, its Q is positive, it's an endothermic. If we started up here and went the opposite direction, that's a cooling curve. Q is negative. It's an exothermic process. Okay, so that is a qualitative view of a cooling curve or heating curve. And in another video, I will be addressing the mathematics of this. Thanks so much for joining me, and good luck as you study chemistry.